folks, how about if we get this show on the road? All right. Welcome to Bio 1120, Cells, Genes, and Genetics. And welcome to Wright State for those of you who are here for the first time. I got to tell you, this is a little intimidating. All right. You look around. This is a big class. But boy, this is one of my favorite classes to teach. I've been on sabbatical leave all of last year, so this is the first time that I'm back in the saddle in about a year. And I've been really looking forward to talking with this class about this topic. This is fun stuff, and again, it's one of my favorite classes to teach. Let me get this out of the way right at the very beginning here. It is my mission in this class to persuade all of you to become biology majors. All right? I think about a third of you have already seen the light. All right? But I got to do some work on the other 2/3 of you. So during the course of the semester, I'm going to keep saying, you know, if you're a chemistry major, you might find this interesting, but it's even more interesting if you think about this from the perspective of biology. All right? And I'll be doing stuff like that throughout. So that's my sort of secret agenda for this class, and I hope that I succeed with all of you in that regard. So we're getting started here today with some sort of gentle introduction, easing into the class. We'll be talking on Thursday morning about some chemistry, interestingly enough. But for today, I want to spend a little bit of time talking with you about the syllabus, introducing you to one person who's going to be an important contact, a helper for you during the course of the class. And then it'll sound odd as I say it right now, but I want to wrestle a little bit with a really fundamental question toward the end of the class today, halfway through the class and beyond. I want to just talk about what does it mean to be alive. Right? This is a biology course. If you weren't sure, biology is the study of life, right? And so if we're going to be studying life in this class for the rest of the semester, it's probably a good idea if we wrap our heads around this idea as to what it is that living things actually are to begin with. And you're thinking, oh my gosh, how low a level of class is this, right? I think you'll be surprised at how complicated a question that turns out to be. But before we get to that, again, let's start with just some of the boring stuff here, this syllabus business, okay? So I've got a PowerPoint running here. We'll be clicking through these slides during the course of today's lecture. I think you've all gotten an email from me about 2 weeks ago, right? There may be a few that have just added to class recently who haven't seen that email. But in that email, I told you that all of the PowerPoint presentations that I'll be using for this class are available through the pilot page for this class. Okay, so this PowerPoint presentation is up there. All the rest of them are up there as well. Okay, and I'm going to be talking about the pilot page for the class to the point where it's going to get you sick in about 15 minutes because it's going to come up over and over again. But this PowerPoint presentation is there. You don't have to worry about writing all this stuff down. It's available to you on the pilot page for the course. It's a fairly standard syllabus as far as syllabi go. All right? Nothing really fancy going on over here at the top. We give you the name of the class. I tell you when it meets. I tell you who I am. And then we go through the meat of the course, the lectures that I'll be talking with you about, and the dates that I'll be talking with you about those different things. You can see at a glance that the class is broken up into 3 parts, and each of those parts ends with an exam. Sorry about that. You know, it's part of the job. I have to give tests. But we're going to start out just by talking really about the fundamental chemistry that underlies all of biology and biological chemistry. And we'll do that through the beginning of October. That October 1st exam date is pretty firm. I shouldn't say pretty firm. That October 1st exam date is firm. Right? So don't worry if there's a tornado that causes classes to be canceled for a couple days along the way. I'm going to make sure we have a test on that day because I know a lot of you have other things on your plate, jobs, families, whatever, and you may need to work your schedules around things like that. October 1st will be the date of the first test. The second test is going to be over things pertaining to cells, cellular biology, and that's going to be on Thursday, November 5th. And then we'll get into the stuff that really tickles my fancy. I'm a molecular biologist by training. That's what I do, okay? And so we'll get into molecular biology in the third part of the course, talking a a lot about how DNA does its wonderful stuff for us. And there's a final exam during final exams week on Tuesday, December 15th. And at that point, we'll part ways until you take another class of mine, perhaps in the spring semester. All right? So that's pretty much the lay of the land content-wise. You'll see that every one of those lectures is paired up with a chapter, some reading material from the recommended textbook for the class. I emphasize the word recommended. It is not required. I'll say a few words about that in just a moment when we switch over to the next slide. So that's the table of contents, more or less, for the class. Here's a little bit of the fine print associated with the syllabus. It's the last page of the syllabus. Don't worry, we're in the home stretch. I said the reading materials for the class are spelled out on that previous page from the recommended textbook, not the required textbook. I've got no secrets, right? Maybe that's a problem for me, but I'm big into open and honest. If you guys have questions for me, I'll tell you exactly what I'm thinking and exactly what I know. Here's a revelation that might surprise you. I'm going to be surprised if I open the textbook for the class myself during the course of this semester. Okay? So if you're wondering how much time you should spend reading, maybe that's a guide to you. What I do to prepare for the lectures myself, incidentally, here is the textbook for the class. If you haven't seen it, this is a book that will make you both strong of mind and body. It weighs about, 40 pounds? And it also lightens your wallet quite a bit. I appreciate that. But what I do to prepare for each lecture, and you probably saw me as you were settling into your seats this morning, is I just go through the lecture notes that I've prepared for the class. The lecture notes are related to what you'll see in the textbook. I've read through the textbook. It's not like I'm telling you the textbook is full of lies or anything. But I read through the textbook. I pulled out what I thought were the most important features, the most important concepts that I wanted to make sure that I could convey during the course of a lecture, and I wrote those down into some lecture notes. So here's an idea, all right? You got to figure out what works best for you, but maybe give this a try. Prepare for the lectures the same way that I prepare for the lectures. Right? Read those lecture notes, skim through them. If you were watching me, I did it in less than 5 minutes. Right? There's only like 5 or 6 pages for most of the lectures. Skim through them, get a sense of what it is that I'm going to be talking about. And then as I'm talking about it, you'll see, oh, and I know where this is leading. I can imagine what's going to happen next. And oh, and there's that strange vocabulary word. I guess that's how you pronounce it. Right? Look at those lecture notes just before the class begins, maybe on your way in, something like that. Take some notes, right? At the end of class, at some point, compare the notes that you've taken with the notes that I've put together and make sure they're roughly in sync. Make sure you're pulling out the same things that I think are important, and that those are the things that you think were important when you were taking some notes. All right? And then when it comes time to studying for a test, go back and take a look at both of those sets of notes again. If you find that there's a disagreement between the notes that you've taken and the notes that I've given you in these lecture notes, again, I've emailed them to you, they're on the pilot page for the course. If there's a disagreement, maybe that's a good time to trot out the textbook, right? And see, use that as an arbiter, the definitive biblical source, sort of. Now go there and see what the right answer really was. And maybe you can come and tell me, hey, you really messed it up. The textbook says this, and yesterday or Tuesday, whatever, you were saying that, and I'd be happy for your help then. Question?
I found an error in the textbook.
How about that? There are mistakes in the textbook. Let's talk about that after class, and I'll send Neil Campbell a mean letter. Right? I know the lead author of the textbook, Neil Campbell. Sadly, he's dead, so it's going to be hard to send him a message. But I did know Neil Campbell relatively well, and it is a widely used and very popular textbook. Neat guy. I was thinking actually as I was walking over here, Neil Campbell, I think he died at 54. I'm getting pretty close to that, so I'm starting to. I worried a little bit about my own mortality as I walked in this morning. All right, so
Maybe that's a good way to use the textbook. Another good way to use the textbook might be this. All of the pretty pictures that you'll see in my PowerPoint presentations, those come from the textbook, right? And so a lot of people learn better by looking at pictures and diagrams and things like that. My lecture notes absolutely suck when it comes to art, right? There is no art in any of my lecture notes. I type, I don't doodle, I don't want to freak people out with my crude drawings. And so if you need pictures to help you pull ideas together, the textbook's going to be great for that. And the PowerPoint presentations may help you with that as well. All right, so enough about the optional textbook. Well, maybe not quite enough. So some of you now are probably sitting there thinking, boy, I got screwed. Why did I buy this thing? It cost $150, whatever. I got good news for you. If you stick it out and you take the next course in the series, the freshman biology course in the spring semester, it's required there. And it's also used for the sophomore level biology courses here at Wright State. So, if you have it, don't return it just yet. You'll get some use out of it with me, and if you take some more biology classes, you'll definitely be using it then. All right, so there's the optional recommended textbook. Here is a required book. All right, this is the lab manual for the course. Everybody takes the lab, all right? Not all at once. Don't worry about that, right? You get broken up into much smaller sections of about 20 students. And you'll go week by week, chapter by chapter through this lab manual. There are things in the lab manual you've got to write on and you have to rip out and turn in, so you will need to purchase a copy of this lab manual. You may have noticed that the author of the lab manual is some weird guy named Dan Crank. Right? That's me. All right? And so I need to give you just a little bit of a warning. I've heard from students in the years before that I've taught this class that this lab manual can be a little bit of a problem. Right? What happens, it seems, is that they start leafing through it thinking, oh, what am I in for here? And they start reading a little bit, and they just can't put it down, and they end up losing a lot of sleep, right? They just read, and then they read it over and over again. So just a word of warning to you, set aside a good chunk of time the first time you crack this baby open, because it's going to be hard to set aside. But I tell you what, there's more good news. Not only is it a gripping read, I wrote it. I know what's in it. I designed these experiments myself to help illustrate the points that we'll be talking about during the course of the class. There are going to be a couple times when the lab gets a little bit ahead of us here in the lecture. There are going to be some times when the lecture gets a little bit ahead in the lab. But I'm going to try hard throughout the course of the semester to remind you, hey, remember that experiment you did? That's why this was interesting and important. What did you find? Or conversely, hey, in another week, you're going to be doing this in lab, and boy, wait till you see the explosion that happens there because it's rooted in what was going on in this concept that we talked about here in lecture. All right? I said it in the email that I sent to all of you. The labs aren't meeting this week, right? The first time the labs will get together will be next week. So you've got until next week to get a copy of the lab manual. Read the experiment before you get into the lab, right? I'm suggesting you read the lecture notes before you come to the lecture. If it's possible for me to demand that you read the labs, I would do that because it'll make the lab a much better experience for you, and it'll go more quickly for you when you're in there. Next week, probably on Tuesday, I'll remind you need a lab manual for the labs. You're also going to need a couple other things like goggles and gloves, maybe a lab coat. We'll see what the prep lab people have to say about that, and I'll get you official word about that probably on Tuesday of next week. Question? The only thing you'll need for the lab in terms of a book is this, right? Yes. So you won't need a graph paper or anything like that. Anything you'll need will be part of that book. All right. So there's a book. There's a lab manual. And then, boy, this is really tediously slow, isn't it? It's taking me 10 minutes to go through the first two sentences up there at the top of the screen. Here's one that may take even more time. That last sentence in that paragraph says ancillary materials, including video recordings of the lecture and class notes, are available through the pilot page for the course. I mean that, right? So, believe it or not, what I'm doing right now is being recorded for posterity, right? So this lecture is being recorded in all its dazzling, 3D animated glory, right? The words that I'm saying are being recorded. All of that is in the images, the PowerPoint, all of that stuff is available to you online through the pilot page for the course. All right? It takes about a half an hour for the system to chew on the things that the files that are being created before they actually get uploaded to Pilot. But certainly by lunchtime today, this lecture will be available to you for you to watch again if you would like. That's not all, right? The words are also being recorded. And what's going to happen is two files will be made. In the past, I've found that some students, and this disturbs me a little bit, but some students seem to really like the soothing tones of my voice as they're driving, right? Or as they're on mass transit. And so not only are you going to have the video recording, but there will be an audio-only version, an MP3 version that you cannot transfer over to an iPhone or whatever you'd like to listen to, and you can just hear me saying these things over and over and over again. All right? So there's both a video and an audio version. And that's not all. Now I'm starting to do an infomercial. That's not all, right? Because not only will you have access to all of this year's lectures through the pilot page of the course, what more could they move on? How about the fall of 2013's lectures for this course? Now, I got to tell you, this worries me a little bit too, because if you start watching the lectures from the last time that I taught this class, the fall of 2013, you're going to find out a couple things that probably are best kept a secret. I only have 3 shirts, right? And I tend to wear my blue striped shirt on the first day that I give a class, right? So there's going to be stuff like that you might notice if you watch the fall of 2000. I've washed it since then, right? Don't be alarmed, right? But all of the lectures from the fall of 2013 are available on the pilot page for the course right now. So if reading the lecture notes helps you get a clue as to what it is I'm going to be talking about, and you're really into this stuff, you might want to watch the lecture before I give the lecture. And you can make comments to your neighbors about how my shirts look strikingly similar and how my jokes are always the same. Wait for it, he's going to say this, and just there it is, It's going to be very predictable. This is highly scripted material, right? Lots of rehearsal goes into preparing one of these lectures. And all of that's going to be available to you on the pilot page for the course. Part of my thinking is this. I don't want to be the reason that you guys have a hard time learning about the stuff that I'm going to be talking about. Believe me, I wouldn't want to be where you are. Come on, you're touching other people. There's a lot of people in this room. There's germs all over. I've wondered for years why people bother to come and sit in those chairs. I can't quite get it, right? And so I'm trying to make it as easy as possible for you to not come to class. That's probably odd. You've never heard a faculty member say that to you before. But I don't understand why you think that you might get something extra by sitting in this room. And I appreciate that some of you are coming from crazy far distances. Students commute from Columbus and all over. It takes hours sometimes for people to come here, and the weather can be crazy in the fall semester. Beginning of December, there's going to be snow all over. I'll be here. The lecture will go on as long as Wright State is open. But you don't have to be, right? And you can watch these at home from the comfort of your bed in your pajamas, drinking a nice warm hot cocoa or something like that. And speaking of drinking hot cocoa, I understand that in the fall of 2013, some drinking games were inspired by my lectures. All right, so there's a challenge for you guys, right? Every time he says DNA or whatever, but and I'm not condoning that. I'm just letting you know. You're adults. Do whatever works best for you. But so you you guys don't have to come to class. And in fact, I just took steps on Friday to have this class officially designated a hybrid course in the university's scheme of things. What that means is that there is a significant online component, these lectures, right? You can watch those. You can come. I'm not telling you not to come. But if you wanted to watch them online, I don't think that hurts you in any way. But you do have to be here for the exams. I can't do those through Pilot. At least I don't care to do those through Pilot. And you do have to be here for the lab, right? And so there's going to be a community sort of thing that happens when we all get together for exams and when you get together for your labs. The thing that I think might be missing from an online type of course, if you did choose to just watch the videos, is the opportunity to ask questions and interact with me directly, to discuss things with me, whatever. And so here's what I propose to do to address that. Right? I've got office hours. I'm actually subtly moving down the page of the syllabus. I've got office hours. I'm going to be sitting in my office during those times, Monday mornings and then just before class on Tuesdays and Thursdays. And my office is 225B in the biology building, so just over there. I've got office hours. I'm going to be sitting there. Come by, chat, whatever you want to talk about. I'll be happy to discuss anything. But before class on Tuesdays and Thursdays, for those of you who want to do this as sort of an online kind of experience, those are going to be virtual office hours as well. So I'll be physically in my office. If you come to see me, I'll be there. We'll talk. But if you don't want to get out of bed, right, you can go to Pilot Live, right? In the Pilot page for the course, there's a thing called Pilot Live, and I will be having virtual office hours so that we can interact that way virtually. I'll be sitting there in my office. We can talk. Other people who participate in Pilot Live can lurk and can listen to what it is that you and I are talking about, whatever. But there you go. You don't have to get out of bed to be able to participate fully in the lecture parts of this class. All right? First time, and actually to my knowledge, I think that's the first time anybody in the College of Science and Math has done anything quite like what I'm talking about doing here. And it's all for you. I just want to make this as easy on you guys as possible. All right. So I've got an office. I've got a phone in my office. I often don't answer the phone in my office. Strange people call me. I'm not talking about you guys. I get a lot of phone calls. You'll hear over the course of the semester I get involved with court cases where DNA evidence is involved. I'm an international DNA profiling expert. Right? So I get calls from all over the world. I was involved with the Simpson trial, Ted Kaczynski, the Unabomber, Monica Lewinsky's dress. I was involved with some of those analyses. So I get interesting phone calls, and I often won't answer the phone, but I'll check my messages. So calling me, I don't know. That may not be your best bet, but you can leave a message, and you may get lucky, and I'll pick up the phone. The way to really reach me is through email, right? I am a fanatic about email. I've got 2 young daughters at home who wake up at strange hours in the middle of the night. I've got 3 puppies at home that wake up at strange times in the middle of the night. And there's something wrong with me in that I can't leave an email unanswered, right? So I'll get back to you with a substantive response pretty much within a couple hours whenever you send me an email. So if you've got a burning question, take a shot, email me at 2 a.m., and you may find that I'm answering you like 5 minutes later, okay? So my guarantee is, on average, my response time will be less than 2 hours. Right? And I think that also is a record for the College of Science and Math. You'll be lucky to get some of those fossils to respond in less than a week. But on average, mind you, less than 2 hours. All right. And again, I got these office hours. If you want to stop by then, and we can talk. All right. This is probably a good time for me to introduce one other person to you. Feeling ready, Lauren? I've softened them up for you. All right. So this is Lauren Ralph. She is the supplemental instructor for the course this year. She took the class in the fall of 2013, did exceptionally well, and now we brought her back to have her help you work your way, navigate through some of the ups and downs of the class. She knows think about these things. She can give you tips for studying. She's the supplemental instructor, and that comes with all sorts of neat stuff. So, Laura, can you say just a couple words to them about how you can help them?
I'm going to be hosting sessions every day after the lectures. I'll give you the times and where. And you can email today. As long as you're registered for the course, I have your email. So if you don't hear from me today, you should probably be concerned about whether you're registered or not for this course. But I'll send you an email later, and you can come email me anytime. I can do my best to get back to you as soon as I can.
So, for those of you in the far back who may not have heard, she's going to have a supplemental instruction session after each of the lectures. Okay, so you can attend those. And she's also going to be emailing everybody in the class later today, right? And so if you don't get an email from her, you should probably talk to me or to her before class on Thursday, and we'll figure out what the problem was. But in her email, she'll tell you stuff like how to get a hold of her and what sort of things will be going on in the supplemental instruction sessions. All right, so there you go. That's Lauren. Use her to the utmost. Okay, laboratory sections. I've already said a little bit about the lab. I don't know that I need to say too much more. Bottom line is this, is you're going to be doing some experiments in the lab. You'll be generating some reports. You'll be answering some questions, and you'll be taking a couple quizzes. Altogether, that's going to generate 100 points toward your final grade in this class. Speaking of the final grade in the class, there is a total of 400 points that you might be able to get for the whole class. 100 from the lab, 300 from the lecture part of the class. Okay? And the breakdown for the points is up there on the screen. There's an exam on October 1st and one in early November. That's worth, each of those are worth 90 points. The final exam's worth 120 points. Add it all up, and we've got 400 for the class. The breakdown for the grades are spelled out there. It's pretty standard stuff, but I give a little bigger target for people to get a C. C's go from 67 to 79%. And I tell you, I wish I didn't have to assign grades. That's not at all fun for me, frankly. But it's part of my job, and I got to do it. Right? At this point, I bet everybody here thinks they're going to get an A or a B, and that's what I'm shooting for. Right? I'm thinking we can pull this off if we really work at it. But let me tell you, it's been my experience that that's not ever how it works out. Right? There are some students who are going to really struggle with some of the things that are going on in this class, and that worries me. I don't like that. And again, I don't want to be the reason that you guys are having a hard time. If your dog gets sick, if you're having a problem with your relationship, if your boss is a jerk, I can't help you with that, and I know that can impact your grades. But if there's something that I'm doing, if I'm using fancy words, if I'm spitting on you too much, right, whatever, if there's something that I'm doing that's a problem, let me know, and let me know sooner rather than later. And I really want to do this. I don't want to be up here just to talk, right? I want to have a communication. I want to have a dialogue here. If there's stuff that I can do better, please let me know. And the sooner you let me know, the better off it'll be for everybody. Okay, so there's that. But it's a two-way street, too. And it's been my experience in the 10 or so times that I've taught this class before that I can predict with pretty high confidence how a student will do for their overall grade based on the score they get for the first test. Okay? Like a 90% correlation. If you get an A on the first test, there's a part of me that thinks I don't even need to bother giving you a second and a third test. Right? That's the happy side. Right? The unhappy side is if you get like a 50 on the first test, I'm pretty sure you're going to get a D or an F in the class by the time it's all said and done, unless things change. And so what we're going to try and do this year is this, is after the first exam, we'll see how everybody did, and anybody who got less than a certain percent, maybe 60%, we'll see how the distribution breaks out. We're going to send an email to and, suggest things that you might do differently, things that might be of help, people that you might want to contact, because I really want to do whatever we can to help you guys right that ship, especially if you're having trouble with that first test. So let me tell you some other things that I've learned from experience. First, a lot of you guys appreciate that freshmen get free tutoring. All right? So there's a tutoring center on campus. If you go and talk to them, if you think you might be having some issues in this class down the line, if you go and talk with them, now's the time to get lined up for that free tutoring, because like midway through the class, the tutors have their schedules all filled up. So you might want to, if you think this is unfamiliar territory or this could be a little scary for you, take advantage of some of the free tutoring. Here's another thing. All of the tests, all of the tests for which I still have a copy of the exam and the answer key are available on the pilot page for this course. Right? Take a look at those old tests. Please take a look at those old tests. I'm going to make a fresh test up for you guys for October 1st, but it's going to look awfully similar to the 7 or 8 other first tests that you'll find on the pilot page for the class. The sooner you look at those tests, the better. Because what you'll find is they will also help you focus your attention in terms of what it is that I'm talking about. It'll give you a sense as to what sorts of things I might ask questions about. But much more importantly, I think it's going to give you a sense about how I ask questions. And it's going to be different. For those of you who are, coming here straight from high school, haven't had a college class before, this is going to be a little bit of a surprise to you, perhaps. I don't care about minutia. I really do not care about your ability to memorize, right? I can memorize, you can memorize, we can all memorize, let's get that behind us. I want to encourage you to think about the concepts in this class. I want you to think about how it is you can use that information. I want you to be able to apply the information, the trivia that we talk about to illustrate some points during the course of this class. There's a good chance you have no clue what I mean by what I've just said. All right? That's why I think it's so helpful for you to look at those old tests, because you'll see I never ask you the definition of a word. All right? That doesn't happen ever. Instead, I'll give you a scenario. That's my favorite kind of question. I'll say, all right, chlorophyll absorbs light best in green. And you're going to think, yeah, that's right? Because that's what we talked about in the green wavelengths of light. That's what we talked about in class. And then I'll say, what would happen, how would things be different if chlorophyll's maximum absorption was here and we lived near a sun that had this kind of a spectrum? I'm going to make it, and you're going to come back sometimes and say to me, that was never mentioned in a lecture, that's not in the textbook. But what I'm trying to do is get you to wrap your head around some concepts and then apply those to solve some problems, because that's when you really understand things. I'm trying to prepare you so that you're in a good position to think critically in the next couple courses that you take. Right? I want you to wrap your head around ideas. I want to fill your head up with ideas and enter a discussion about ideas. And if you need a particular thing, like what's the molecular weight of guanine, right? You know how I find out the molecular weight of guanine? Years ago, I memorized it. I know somebody knows the molecular weight of guanine. I look it up. I crack open a book, more likely. I search on Google, right? And that's what you guys are going to do too. So we don't have to worry about those little bits of trivia the way that people used to have to worry about them 50 or 100 years ago. We need to worry about how to use that information and how to decide if this is important and useful information or not. That's what this class is going to be about. And look at those old tests. I tell you what, I think what we're going to do is this. If you haven't looked at the old tests, we're watching you with Pilot 2. You look at my stuff. I look to see if you're looking at that stuff. If you haven't looked at some of those old tests, in like 2 weeks' time, we'll send you an email saying, hey, I wasn't kidding when I said you should look at some of those old tests. Here's how you do that through Pilot. Okay? Because I think that's going to help you a lot. All right. Last. In early December, about 10% of the class, about 40 people, are going to be coming to me and suggesting that my car might need to be washed, that I may need to have some reports prepared for me on some esoteric topic, all thinking that that might be a way that they can improve their grade. Okay? That's not how you get extra credit for this class. Let's just get that out of the way right now. My car is just fine, thank you. I don't need it good shape in terms of my beer supply. I'm okay. Right? If you want extra credit for the class, here's the one and only way you can get extra credit. Write for me an exam question that I can put on one of the tests. Okay? I like this idea a lot because it forces you to think about the concepts in the class. It forces you to think about how it is I phrase questions and thereby get more comfortable with receiving the questions from me. And it conceivably will save me a little time in putting together an exam. Okay? Well, it's good. It's a win-win-win all around the board here. So if you wanted to write a question that I could put on an exam, let me tell you, I get a lot more of those extra credit submissions at the end of the semester than at the beginning. So if you want extra credit, I'm telling you, maybe start thinking about it for the first test. You'll be alone. Nobody else is going to give me one. For the first exam, it'll be easier to get one of your questions on. But if you want to write one of those questions, look at some of those old first exams, see how I phrase a question, see what sort of things I ask questions about. Maybe take a question that I've used 5 years ago and update it, modernize it, right? Here's a new discovery that may change the way you think about this question, right? That would be a great strategy, a great way for you to get extra credit. And again, that's the only way that you'll get extra credit. For each question that you give me, that'll translate to, it's a 0.5% of the final grade. I think that's 8 points, as I recall. So it's, I'm not joking around here. You can get some serious extra credit. And there's no limit to the number of questions you can give me. Right? So you can give me 50. The only limit is there are only 45 on each of the first 2 tests. All right? Is there a question? You can write, you know what you might want to do is write 90 questions, and I'll pick the half that I like best. All right? So yeah, there's no limit to the number of questions you can give me. What I think you might find is this, is give me a question and then come back and see me, like, if you give me a question on a Tuesday after class, on Thursday come back and ask me about it, and I'll probably be able to give it back to you with a few suggestions for ways to change it. All right? And if we work at it, after just 1 or 2 iterations like that, I think we'll be in a position where you'll have given me a question that I feel comfortable putting on the exam. All right? So it's not a one-shot deal. You can give me the same question 50 times, but hopefully it's incrementally improving each time. Okay. So there's the syllabus. Any other questions for me? That's sort of like the contract for the course between you and I. Yeah. Wow, you're late. So we aren't going to send you the email. You've already checked one of the old tests. The question is that there's a question on one of the first old exams that there's a question, there's words, and then there's a blank space where I had hand-drawn in some chemical structures. Okay? So what you've got there are the Microsoft Word documents that I created, not the actual test that got handed out to everybody. And the only difference is that, I don't know, for about 5 or 6 questions, I probably had to write in some structures that I couldn't do easily in Microsoft Word. I don't have those handwritten things, but from the context of the question and what we'll talk about in class, I think you'll get a pretty good idea as to what those structures might have looked like. That's the sort of thing that I'd be happy to talk about during office hours and so forth, if you like. Okay? Anything else? Yeah. I won't give you extra credit unless I actually use your question on the exam. Okay? And I'll leave it up to you as to whether or not you want me to mention your name on the exam or not. I don't know. I got to tell you guys, it's a real rush talking to a group of 400 students, right? This is your 15 minutes of fame if you get your name out there on an exam that 400 people are going to be agonizing over. But then again, if your question is difficult, you may not want to be associated with it. Yes? Yeah, she's asked if these should be multiple choice or short answer questions. Look at the old exams, and you'll see it's just not feasible for me to have short answer. That would be my preference, but it just can't be done with 400 tests that need to be graded. So yeah, multiple choice. They're all going to be, the exams will all be graded by a Scantron machine, right? So they have to be multiple choice. Okay. Anything else? Yeah. If you wanted to send me your question as an attachment or as part of an email, I'm fine with that. So, however you get it to me is good. If you want me to give you feedback, a hard copy is usually better because I can write on it. Yeah. I'm not worried about, so she's asking if like 3 or 4 people submit the same question, how would that work? I'm not that worried. I don't think I'm going to get a lot of questions for the first test. I think I'm going to get a lot of questions for the final exam, based on my experience. And I've never had in 10 times that I've taught this class, I don't think I've ever seen a pair of questions that looked disturbingly similar. So I'm not too worried about that. If it is, we'll cross the bridge. We'll split the credit. We'll give everybody credit for everybody. I don't care. Yeah, yeah. That's a good question. How far in advance do I have to have the question to get it on the exam? I'll tell you the way that again, I got no secrets. Here's how I'm going to put the exams together. For you guys, I think what's going to happen is this. In the lecture notes that I sent to you electronically, which are available on the pilot page for the course, there is a copy of each of the 3 exams that I gave in the fall of 2013. Okay? What I will do, that's a Microsoft Word document in my world and on my computer. I'm just going to copy that document. I'm going to copy that exam 1 and put it into a new file and then go through and say, oh, that's a bad question. Let's get rid of that one and replace it with something else. And I'll work through. Some of the questions will be similar or the same. Some of the questions will be completely different. I may go to a couple of years ago and find a few questions. Practically speaking, to get the 400 copies made up, I need to have the exam ready. If the exam's on a Thursday, I probably have to have the exam finished by the afternoon of the Tuesday before. Right, so give me if you want a question on an exam, you should probably get it to me at least 2 days before the test. I think we're done. All right, so it's a deal. That's the syllabus. That's how things are going to play out now for the rest of the semester. Let me take a breath and let's start talking about some of the actual fun biology stuff associated with this class. So, we're all going to settle into a routine during the course of this semester. And part of that routine, is this an assassination attempt? All right. Part of that routine is people are going to come down and hit me and stuff like that. But in addition to that, I'm going to have a lecture outline that I'll go through during the course of the lecture. So we'll keep touching base on this. I'll remind you often where it is we started and where we're going with the things that I'm talking about during the course of the lecture. And again, all of this stuff is part of the lecture notes. If I change some wording or if I change something about the PowerPoint, all of that stuff ends up getting on the pilot page for the course. Right? So none of this should be a surprise to you when you're coming in here to the lecture. But today, in the half hour or so that we still have left, let's wrestle with a really profound, deep question. And I said, 45 minutes ago, I said biology is the study of life. Period. Plain and simple. That's what this class is about. You know what chemistry is? Chemistry is the study of matter and how it interacts with itself or with other bits of matter. Astronomy is the study of heavenly bodies. Right? Pretty much every discipline has its own special niche. Biology has the coolest of all of the niches. It's the study of life. I say in the lecture notes, why do people bother studying economics? Right? What's the point of that? They study economics because they think it's going to help them get a happier, healthier, more comfortable life. You know, you guys are cutting to the chase. You're studying life itself. How better to make sure you have a happy, comfortable, healthy life than by studying life? I mean, that's what we're doing here. So biology is the study of life. And that begs the question then, well, so if biology is the study of life, what's alive? What's life? And again, it's a profound question. You guys probably have never wrestled with that question before. It's the sort of thing that my 5th grade daughter, if I take her outside and I show her the concrete of the driveway in one of our new puppies and I ask her which of those things is alive, she's going to think I've been having some mental problems or something. It's obvious. Is this step alive or is this guy alive? Oh, come on. We all, it's not that hard for us to come up with those answers. But how did you arrive at that? Not many people take the time to stop and think, what is it about something that's alive that makes you recognize it as alive? And we can all agree. And what is it about something that's not alive that we all recognize and agree makes it not alive? It's a surprisingly difficult question to answer. And yet, if we want to be biologists, if we want to study life, it's a good idea that we at least give the matter some thought. So, let me tell you, philosophers have wrestled with this for millennia, for thousands of years. And the consensus seems to be that living things tend to have some combination, usually all, of at least 4 different characteristics that non-living things tend not to have. Okay? And those 4 things are listed up there under the basic characteristics of life. I'll cut to the chase. Organization, the ability to reproduce, the ability to respond to stimuli, and the ability to repair damage. That's it in a nutshell. But let's think about them just for a moment, a few minutes, one at a time. Right? So the first on the list there is organization. Living things tend to be more organized than non-living things and their surroundings. Right? There's a boundary between where me as a living thing begins and where me as a living thing isn't there anymore. Like right over there, that's not alive. Right, like 2 inches from where my fingers are pointing, that's part of something that's alive. Right? And so there's this boundary. And for me, that's skin, right? But at a smaller level, it's cell walls and cell membranes and tissues and so forth. Living things have these boundaries, and on one side of the boundary, stuff is more organized than on the other side. There's strange concentrations of salts and water and proteins and chemicals that are organized in a way that's important for me to maintain myself as a living thing that you wouldn't find in a non-living thing. Right? So there are these boundaries. And you could say that a living thing is like a little island of order in a sea of disorder. Okay? But wait a minute here. Islands are a little island of order in a sea of disorder as well. I'm talking about real physical islands like the U.S. Virgin Islands or something like that, St. Thomas, St. Croix. There's a boundary, the beach, right? On the outside is all that mushy, watery stuff. On the inside of the boundary, you find organized structures, certain chemical concentrations and structures that you don't find on the other side of the boundary. This idea of organization, diamonds, man, that's incredibly organized at a molecular level, depending on what you're talking about for organization. That may not do it for you. If you used organization as your sole criteria for deciding if something was alive or not, I think we'd be getting the wrong answer a lot. A chair is pretty organized, right? I don't know how often these chairs get washed. I'm pretty sure these are the same chairs that were used, the first time I taught this class 10 years ago. They may be alive, but, in the normal sense, we don't worry about chairs being alive, even though they're pretty organized compared to other stuff around them. So organization, good indication indicator that we're talking about something that's alive, but apparently not the be-all and end-all that allows us to discern between alive and not alive. So let's move down the list. How about this ability to reproduce? Again, I got no secrets. I told you I worried about my own mortality as I walked over here today, carrying Neil Campbell's book, thinking, boy, a guy who wrote a book that weighs 30 pounds you wouldn't have thought would have died from a massive heart attack. He should have had good cardiovascular shape, right? Because lugging that book around's a workout. But here's another thing. Probably best that I don't share this with you, but I already told you I've got 3 dogs. There's something wrong with me for that, right? We just adopted 2 about 2 months ago now. A week from today, before I come into class next Tuesday morning, I'm dropping the 2 baby puppies off at the vet, and there's going to be a special operation that they're going to have that will make them no longer able to reproduce. All right? Now, there are times that I'm pretty frustrated with these new dogs, but if you were to tell me that that actually killed them, if you convinced me that they're preventing them from being able to reproduce in some way killed them, I'd be really sad, and I might even get mad. I might want to argue with you about that point because I'm optimistic that after the operation is over, I'll pick them up later in the afternoon, and they're not going to appear to be that different to me in terms of their vitality compared to when I dropped them off in the morning. So, and many of you have not had children yet, right? Does that mean you're any less alive than an old guy like me who has? I don't think that would be a reasonable argument. So this reproduction thing, right? Yeah, okay. I think it might be important as a feature of a living thing that sometimes there's a capacity to reproduce, but apparently, again, that's not the be-all and end-all of whether or not something's alive or dead. And check this out, right? Not being able to reproduce doesn't necessarily mean you're dead. Neil Campbell can't reproduce. So, he's not doing so well in that regard. But, at least not anymore. But, what about the flip side? Can things that we all agree aren't alive reproduce? Right? I bet you didn't know this. If you took a star like our sun and you passed it through a cloud of hydrogen gas out in space, you know what the sun would do? It would accrue more mass, right? It would suck up that hydrogen, would get bigger. It would, depending on the physics, most of the time it would start to spin faster as it was taking in this additional hydrogen, this additional mass. And what often happens when suns take on mass in that way is they start spinning fast enough that they actually send out a little baby sun that can, in its own right, start sucking up hydrogen gas, star food, if you will, and get bigger and become another sun. Stars, suns, can reproduce in some meaningful way to stars and suns. And so the ability to reproduce at a first pass looks like, yeah, that's a good one, right? But it turns out there are non-living things that, yeah, it's hard to argue that that's not reproduction. And there are living things that just can't reproduce, and you're still feeling pretty good that they're alive. And so, darn, number 2 on the list isn't going to be the be-all and end-all that tells us that something's alive or not. So let's go further on the list, right? The ability to respond to stimuli. That's a good one. How many of you guys are living in the dorms here at Wright State? Have you done this experiment yet? Like 2 o'clock in the morning as you're sending me an email? Tonight, perhaps do this. Turn the lights on as you're sending it up. Do you notice anything scurrying around? Right? Those are cockroaches, right? And they're responding to stimuli, right? They don't like the light. That's a stimulus, and they're programmed to respond to that stimulus, right? You know what I'm talking about, right? Have any of you ever done this experiment, like at Thanksgiving when you go home and your grandma's asleep on the couch and it's time to eat, right? Does it ever cross your mind, I wonder if she's sleeping or if maybe something else has happened here that I need to be worried about? What do? You go and you poke Grandma because you're hoping that she's going to meet this criteria and still be able to respond to stimuli. If she doesn't respond to that stimulus, a whole different sort of things start to happen at the house than just having a nice Thanksgiving dinner. Right? So we expect non-living things to respond to stimuli. It turns out that we need to be mindful as to what the stimulus is. A stimulus that might excite us may be utterly uninteresting and unimportant to some other organism, right? Something that, there's so many examples. I don't know that I even need to give you one. It's just, each organism has its own special set of stimuli that it might respond to. Here's one. Plants are pretty interested in the angle, the direction from which sunlight is coming from, and they can respond to that stimulus, the sunlight, by moving their leaves in a way that gets the maximum exposure to the sunlight, right? We really don't care, right? Oh yeah, once in a while we might be interested in sunbathing and we want to figure out where the sun is, but it's not nearly as important a stimulus to us as it is to plants. You and I might be really excited by the smell of a fresh steak, right? Sunflower plant, what's it care, right? So some organisms, well, all organisms have their own special set of stimuli. And so we need to pay attention. We need to think critically a little bit about what stimulus, when we say respond to a stimulus, you might need to say, well, what stimulus? It needs to be a stimulus that's important to the organism. And when you start thinking that way, did you know that you can actually train an iron bar with a magnet so that it becomes increasingly responsive to the magnet? You change the molecular structure of the iron by repeated exposure to a magnet. You can change the flexibility of iron by bending it repeated times, right? So you can condition, you can train, you can get non-living things to also respond to stimuli. Stars, right? We just gave them some airtime a few minutes ago. Stars are drawn toward their food, right? The gravity associated with a hydrogen gas cloud would bring a star more closer to it, right? That's an important stimulus to a star, right? And so that criteria doesn't seem to do the job either, because we can point to a lot of examples of things that we all agree aren't living that also might respond to stimuli. Okay, so that one's not doing it. And what about this last one? The ability to repair damage. Right? There's an expectation that a living thing can become whole again if you damage it, but you haven't done too much damage to it. Right? If you cut me, I'll bleed a little bit, but if you haven't cut me too badly, in a couple minutes, maybe 10 minutes, I'll form a scab. In a day or two later, the scab will come off, and I'll be largely none the worse for wear. Right? I've repaired damage, and you may even have a hard time 2 weeks after the fact knowing that I had had some damage. Right? So that's something we kind of count on and we expect for living things. But if you had a big enough scalpel and you took a wedge out of a star, right, took this little slash at a star, not a little slash, a monumental slash at a star, what would happen? Right? If you didn't take too much of a chunk off of that star, the star is still going to stay a star, and it's going to form a sphere again, and a week or two later, you may not have any way to tell that you had taken a slash at that star. So non-living things can also repair damage. So we've gone through now 4 criteria, right? And at a first pass, I think each of them you think, well, yeah, of course living things can do that. But if you think just a little bit deeper, you find yourself thinking, oh, but wait a minute here. I guess that's not as clean and hard and fast a rule as I would have thought. And even when you put all 4 of those things together, you find yourself kind of equivocating, I think, in terms of whether or not something's alive. And again, it's something that we all learn, like when we're 6 weeks old, babies can discern, but they're more interested in living things than non-living things. Their eyes light up. They're drawn toward. They respond to that stimulus. It turns out that it's a pretty hairy question when you stop and think, what is it that makes me understand this is a living thing as opposed to a non-living thing? And yet biology is the study of life. That's what we're here for. And I'm telling you, I'm a full professor, right, of biology, and I can't give you a hard and fast set of rules in terms of where it is I need to, nope, I'm not studying that. That's not alive. I only study living things, right? I can't do it. If you guys came into this class thinking that you could, I hope now you realize that it was kind of naive, right? It's a dicey question. And now you may be wondering, why are we even bothering studying life, right? What's the deal? What's going on? Why did I even, am I trying to dissuade you? I'm trying to dissuade you from coming to the class and just watching it online. Now am I trying to get you to drop the class? No. I'm hoping you may take away from this little discussion about the characteristics of living things is that there's a continuum of life. There's a really broad spectrum of things that we say are alive, and it covers a really wide range, and the boundaries of this continuum are kind of fuzzy, and we blend casually into non-living things, right? Such that there may be some important things we can learn about living things from examining carefully some non-living things. That's pretty much my whole point for the last 15 minutes or so. I'm trying to lay a foundation, a justification for the torture I'm going to put you through for the next couple of lectures when I talk with you about things that are unequivocally not alive, things that are subatomic particles, things that are chemical compounds. As I talk with you for the next 2 or 3 lectures about chemistry things, the reasons that I'm making you endure that I'm putting you through that torment, is because there will be some important lessons that we learn from looking at these non-living things that will help us get a much better working understanding of the living things that we'll be talking about after we get that painful stuff out of the way. Okay? So I'm asking you, bear with me. For the next couple of lectures, I'm going to talk with you about pH. Oh my gosh, what a snoozer that is, right? But I'm doing it because it turns out that the understanding of that kind of chemistry turns out to be really important to the way that living things are playing the games that let them be living things. So my point, we can learn some good stuff about life from looking carefully at some non-living things. And I should have been advancing some slides here. I'm out of there. Which of those things is alive, right? My older of the 3 dogs is a beagle, so don't be telling me. She's had the operation, by the way, and she's still alive. That's not my beagle. It's just a picture of a beagle. And there's a sun. That's actually our stuff. All right? So, right, no question which of those things is alive and which one isn't. And yet, it turns out to be a tricky question. There are some neat things about that bind all living things together. There's an underlying unifying chemistry. Okay? The structure that you see up there is a DNA molecule, one of my personal favorite topics to get into discussions about. But it's a DNA molecule. It's a chemical. Okay? DNA, deoxyribonucleic acid, it's a chemical, just like hydrochloric acid and water and glucose. These are all different chemicals. It follows a set of rules that chemicals need to follow. Again, that's ultimately what chemistry is all about, what those rules are. To really understand how DNA can play the neat role that it does for living things, I need to take a little bit of time for the next week or so to talk with you about what those chemical rules are, and that sets us up then to better understand how it is DNA can do the stuff it does. And there's another reason I put that DNA slide up there. There is a unity of all living things on this planet. Feels sort of like a Disney movie now. I don't know. But, we're all related, not just as human beings, but all living things. We share a single common ancestor. That's what evolution is all about, by the way. We have a common ancestor. And one of the proofs of that is the common use of molecules like DNA. Right? It's an underlying unity, an underlying chemical unity. We're all glucose-based organisms. We all rely on glucose for energy transfer and to some extent for energy storage. We all rely upon some variant of DNA or its close relative RNA to store our genetic material, to store our instructions, the blueprints that let us do all the other things that we need to do. If you're not comfortable with evolution, you're probably of the the other predominant school of thought is a creationism sort of approach, that God came and touched things individually and set them up. What an unimaginative God to always use that same molecule. Right? Why not come up with a different, bacteria will let you use this for your storing genetic instructions. Plants, you use this for storing genetic instructions. Everything uses that same strategy, the same approach. Turns out that there's advantages and disadvantages to that. If we had an imaginative God that created everything independently, it would be a pharmacist's dream come true, because every organism would have its own special chemical makeup, and it would be really easy to mess it up. It'd be really easy to find a chemical that would really mess up that organism as opposed to everything else. It's a struggle for pharmacists now, though, to find drugs that take out the infecting bacteria but don't harm you. And part of the reason that it's a struggle is because we share so much fundamental basic chemistry in common. Okay? That's the downside to there not being an imaginative God that created everything completely de novo, from independent of all the rest. The upside, I should say that better, the upside is that by studying things like bacteria, figuring out how they do things, we can usually count on getting really deep insights into how it is we do things as well, without having to have done the experiments on a human being. So when you crack open an E. coli, the sort of the lab rat of microbiologists, bacteria that lives in our guts, when you crack open an E. coli and you discover that it synthesizes a chemical in a certain pathway, it starts with this and then moves to that and then moves to this and then delivers you the final product, there's a really good chance that we are doing it the same way. And so you don't have to bother experimenting on humans or dogs or even soybean plants when you have ready sources of information from things like bacteria. So that underlying unity associated with all living things has advantages and disadvantages. Okay? And we're going to be counting on those a lot for this class. In fact, a lot of this class we're going to spend talking about that fundamental chemistry as we learned it from prokaryotic organisms and then extrapolated to eukaryotic organisms. That's what I meant by that fundamental chemistry. Above that, there's that line that says reductionism versus holism. This is just words of wisdom from a guy who's starting to get some gray hair. All right? People tend to think about things in one of two ways. They either break it down to its smallest possible components, or they look at only the big picture. Reductionists focus on the minutia. Holistic people are looking for the whole big kielbasa. All right? We're starting this class as reductionists. We're going to be talking about subatomic particles moving up to atomic nuclei, then to some compounds, then to some macromolecules, and then finally to some things that are cells. Right? So we're starting at the reductionist end of the spectrum for this class. As the semester goes on, we'll be getting to bigger and bigger things. But it won't be until next semester, if you keep taking this series of classes, that you start to see the holistic perspective. Here's the wisdom that I have for you. Remember, when I'm talking with you about subatomic particles, it all has to come together in some way to make sense as part of the holistic perspective as well. But for my mind, more importantly, when you're not listening to me prattle on anymore, you're in David Goldstein and Don Cipollini's class next semester, and they're talking with you about ecosystems and pumas and leopards and all those fun things. Think back also. Remember to think back at a molecular level how it is those things have a lot in common and how they're using the same strategies to accomplish the same processes. Right? So when you're thinking about biology, the study of life, I want to encourage you to always bear in mind, even if you're focused on some little tiny detail, it's really part of a bigger picture. And if you're looking at the big picture and focusing on the big picture, remember it's all underpinned with lots and lots of little tiny detail. Right? So that's what that reductionist versus holistic stuff is about. And again, this diversity business. I've already given you a little bit of a spiel about this underlying unity associated with all living things. And I gotta take now the next 5-10 minutes just to talk with you a little bit about evolution. All right? I've already mentioned that nasty E word that gets some people pretty nervous. I know from experience that given the demographics of where we live, on the order of a third to maybe a half of the people in this room have really never had a good, thoughtful consideration of what evolution is. In fact, some of you may actually be afraid that I'm going to cause you to have eternal damnation by opening your eyes now to this idea, because it's just never been something you've been allowed to talk about. I've talked with high school teachers. They're really uncomfortable talking about evolution because there's a lot of pushback that they get. Well, here's the deal. This is a science class, all right? This is a biology class. It's a science class. The single best explanation for how life came to be on this planet as we know it is evolution. It's the single best scientific explanation. Now that I've left that hanging in the air, let me tell you this. I was on sabbatical leave all of last year. Okay? I spent that whole year at the University of Notre Dame. Famous. It's the most Catholic institution in the country, perhaps in the world. If nothing else, that brands me as a Roman Catholic. Right? I'm a pretty religious guy. I was at church on Sunday. I went to Mass every morning that I was at the Notre Dame campus, and there was a Mass available. Did you know they have a Mass every hour of the day at some point on Notre Dame's campus? So it's hard to not go to Mass if you're at Notre Dame. So I'm a religious guy. Right? I want you to understand that I don't think that religion has nothing important to say about life. That's not my position here at all. I think that religion and theology and philosophy give us really important and valuable insights into why life is on this planet. Not how life came to be on this planet, but why. Theology, philosophy, they give us insights into the purpose of life. Right? Is there a meaning to life? Is there some consequence to what we do? Are there certain standards, morals that we should follow, rules that we should follow once we come to understand them? Right? Theology is where I look, and I want to know everything that I can about life, by the way. Right? I don't want to close off the avenue of understanding life from the theological or philosophical perspective. The why of life is personally very important to me. The how of life is also personally very important to me, but I don't go looking to the Bible to help me understand the how. I look to the Bible to help me understand the why. The how questions are questions that science answers. Science looks to explain things through natural laws. Okay? Theology essentially involves the suspension of natural laws. Right? When the rules that normally apply didn't apply, now we're starting to talk about a theological explanation. The best scientific explanation from beginning to end for how life came to be on this planet is evolution. Okay? And I see a really important distinction between the two. So this is a science class. I'm not going to bother you with my thoughts about Vatican II or how cool the priests of Holy Cross are. That's the founding order for Notre Dame. I'm not going to. If you want to talk with me about that during my office hours, I would be delighted. All right? If you want a souvenir from the home opening football game, Notre Dame's hosting Texas on Saturday. I'll be there in the president's box, by the way. I'm happy to bring you back a souvenir. But if you want to talk about the evolution of life, the science of life, that's what we're going to be doing in the course of this class. And it's going to be woven throughout the whole class. So this isn't the only time I'm going to be talking with you about evolution. I see the antsiness means that you guys think that we're almost done. There's still a couple minutes left. So let me share this with you. Let's take this out of the charged arena of talking about theology and science, right? And let's move it into another area that I think we can all agree. can about life. There are other people who are less interested in knowing about life and more interested in learning about history sorts of stuff, right? I don't know what their problem is, but there are such people. So say you found somebody that really wanted to know everything they could about the D-Day invasion that ended World War II in Europe, right? You can do that in a historical way. And a historian doing that would be well served to think about it in two different ways. They could do it very historically, scientifically, right? Focusing on how many bullets were fired, what the weather was like, the temperature, the wind directions, how many bombs got dropped, how many liters of blood were spilled at a particular beach, right? A Nazi historian and an Allied historian would ultimately be able to reach agreement about all of those particulars, right? If the Nazi guy said, no, there were only 10,000 bullets fired at this battle, not 10,500, they could go back, they could look at records, they could count shell fragments. There are ways that they could ultimately arrive at an agreement and figure out what the basis of their disagreement was. But a historian who wants to understand the D-Day invasion would also be well served to think about the idea of the battle of good versus evil, right? That's an awfully important consideration when you're thinking about something like that. And yet a Nazi historian and an Allied historian would not be able to reach agreement about which prevailed in that battle, good or evil, because there's a fundamental departure and they can't even agree on the very basis of what it is that they're discussing or arguing. That's the difference between a sort of philosophical discussion and an analytical or scientific kind of discussion. So again, maybe that gives you a little bit more of a perspective about what I mean when I say that evolution is the best scientific explanation for life on the planet. Personally, I look to something like the Bible for the purpose. There are other ways that you could look for what the purpose of life is, but let's be open to the idea that science is what we're going to be talking about in this class, and in the words of Theodosius Dobzhansky, who none of you have ever heard of, but is often talked of as being the founding father of the field of population genetics in the United States. How's that for some trivia for you? And it's a cool name. Theodosius Dobzhansky is famous in some circles for having said, nothing in biology makes sense except in the light of evolution. Right? That's going to be a unifying theme for pretty much everything that I talk with you about in this class. And if you find yourself wondering, how does this all hang together? You may want to come back to this root principle of evolution to help you make sense of some of the other things I talk about this semester. All right, now we're done. All right, see you guys on Thursday, and have a good afternoon.